Okay, so back to uh, back to my equation here. Instead of writing the nth term, I'm going to replace it with a sub n. Okay, little a, little with a subscript of n. And also remember that the geometric sequence definition is after the first term, the succeeding term is being multiplied by its preceding term. Okay, so let's put it this way, is after the first term, the succeeding term of the sequence is got from multiplying its preceding term by a fixed non-zero number and that non-zero number is called the common ratio. Okay, so again, instead of saying nth term, I'm going to use a sub n, and instead of saying non-zero common ratio, all of this, I'm going to use little r as my common ratio. Okay, so my nth term is going to be, now remember, I have to use that first term. So instead of that, so my first term, I'm going to go ahead and stick with this terminology here. So my first term is going to be that little a first term, and I'm going to multiply it. So I don't need anything because I'm using variables. I'm going to multiply it by that common ratio. And don't forget, it's the nth term, so I need it before that nth term. So it's going to be to the n minus 1. So I know it's confusing, and it's not an easy thing to do to come up with that. Um, we call this just the, in this case, it's going to be the general equation for the nth term for this sequence. Okay, so um, this is a formula for the nth term for this sequence. Okay, and we'll go through the problem step by step. Okay, Number 5. So this is my answer for the nth term. Number 5. Identify each of the following sequences as either arithmetic, geometric, or neither. If the sequence is arithmetic or geometric, write an expression for the nth term. Okay, so let's see. I'm looking at the numbers 6, 18, 54, and 162. Well, I know to get from 6 to 18, I can multiply it by 3. Um, and actually, 18 times 3 is 54. So this is being multiplied by 3. Okay, so the nth, now we got to come up with the expression. So it's being multiplied, it's a geometric sequence because it's multiplied. And I got to find the nth term. So I'm going to use my new terminology. Little a nth term equals, okay, first my first term, a sub n, and my r to the n minus 1, where my r is going to equal 3. Okay. So, for example, if they wanted me to find the fourth term, okay, so I'm just going to show you how this works. To find the fourth term, so I need n equals 4 for the fourth term. Example, find the fourth term. So I would just plug in 4 for my n. So my nth term, a sub, now we're finding 4 for our n, would equal my first term, which is 6. Now this time I'm going to put a dot here because I'm working with numbers. My r was 3 to the, I'm substituting in 4 for my n minus 1. So my fourth term equals 6 times 3 to the 4 minus 1 is 3. And let's see, 3 to the third is 27. 6 times 27 equals to 162. Now, if I look at my sequence here, my fourth term is 162. So it's a lot of work, and sometimes it's hard to understand, but it to getting this general formula for the sequence is not an easy thing. Okay, let's look at B. I have 1, 2, 4, 7, 11. Let's see. I add 1, get 2, add 1. Nope, that doesn't work. See, I multiply by 2. See, 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 7. Nope, that doesn't work. From 7 to 11 is 4. From 4 to 7 is 3. So I'm adding, see this one, I'm adding 1, I'm adding 2, adding 3, adding 4. So is this a sequence? Hmm. That has to be a constant term. Can't just say, okay, we can if we look at the definition of our arithmetic sequence here, bring it back up. Let's see, arithmetic. The next term is always found by adding the same number to the previous term. So looking at this problem, we are not adding the same number to the previous term. The number is going up. Although it looks like some kind of a pattern, this is not a sequence because that number is changing. All right, C, negative 16, negative 20. Oh, this one's easy. We're adding negative 4. Since we're adding the same number, this is an arithmetic sequence. All right, so the nth term, let's put it over here. The nth term for this is going to equal our first term, little a's first term, and the first is going to represent by that subscript. It's an arithmetic sequence, so we're going to add the add sign, and we're adding negative 4. Okay. And it all depends on what that second term is. Okay, so the first term is going to be that 1, but for that, it's always going to be the 1 before. So we need that n minus 1 for the nth term. That's the 1 before. So there's our sequence. The nth term is the first term, and that first term we're adding negative 4. But don't forget, we always need that we need that term before the nth term. So that's why I got that n minus 1. So let's check this one out. Let's see, suppose I want to find the third term. I want to find when the third term. So third term. N equals 3. So I'm going to substitute in wherever I see an n, I'm going to substitute in that 3. So the third term is going to equal my first term, which is negative 16, my first term, plus the nth term. Well, I'm going to substitute in 3 for my n times negative 4. So I have negative 16 plus 3 minus 2, 1 is 2, times negative 4. So I have negative 16 plus 2 times negative 4 is negative 8. Negative 16 plus negative 8 is negative 24. So my third term, or ace of 3, equals negative 24. Let's check it. Third term, negative 24. So I know I got that formula right. for this sequence. Okay, not an easy thing to come up with that formula. Working backwards, I'm not a big fan of it. Let's see. Let's look at another sample. Okay, well, let's try it. All right, number 6. Can always identify sequence for the first couple of terms. It might be possible to generate more than one sequence from the first 2 terms. Okay, write the next 5 terms of the sequence if it's arithmetic. So if it's we're adding a number. So to get from 2 to 10, I'm adding 8. I'm adding 8. So I have to add the same number. 18, add 8. 26, add 8. I get 34. And then it says, write an expression for the nth term. So here's my nth term. My first term, a sub n, and I'm adding, I need the 1 before the nth term, so I need the n minus 1, and I'm going to add those many 8s. Okay, so we have the 5th term here, it's 34. Let's see if that works. Let's figure the a sub 5, the first term, 2 plus my n is 5, 5 minus 1 times 8. So the 5th term is going to equal 2 plus 4 times 8, which equals 2 plus 32, which equals 34. Sure enough. Now let's do it as a geometric. Same sequence, but geometric. Well, to get from 2 to 10, I'm multiplying by 5. So my R is going to be that common ratio of 5. So my nth term is going to be that first term times R raised to the n minus 1. Let's check it. Let's do the next one. Let's say n is 3. Let's figure out for n3. A sub 3 equals my first term is 2 times R, which is 5, raised to the n, which is 3 minus 1, 2 times 5 squared, which equals 2 times 25, which equals 50. And sure enough, if I multiply 10 times 5, I get 50. Okay, so I think that should be enough for your homework. If you have any questions, as always, email me and I'll be happy to answer them.